Want to build amazing things with Python? Understanding classes and objects is your first big step into a powerful programming paradigm. Object-oriented programming, or OOP, helps structure code, mirroring real-world entities. It's fundamental for creating complex and maintainable applications. Today, we'll explore object-oriented programming, or OOP, a method that helps organize code, promote reusability, and model real-world concepts effectively. By encapsulating data and behavior, OOP makes programs modular and easier to understand. We'll cover classes, objects, constructors, and destructors, breaking down each concept step by step for beginners. Our goal is to demystify these core OOP principles, providing clear explanations. You'll gain a solid foundation for object-oriented Python applications. First, let's understand what a class is. Think of a class as a blueprint or a template. Just like an architect's blueprint specifies a house, a class defines common characteristics and behaviors for its objects. It's a conceptual design. Just as a blueprint provides the design for a house, a class defines the structure and behavior for objects. It specifies data an object can hold, called attributes, and actions it can perform, called methods. This ensures consistency for instances. It's a logical entity that doesn't take up memory until an object is created. A class is merely a definition, a set of instructions. Only when you instantiate an object is memory allocated to store its data and execute its behaviors. In Python, you define a class using the class keyword, followed by the class name. For instance, classCar defines a new class. The indented class body contains attributes and methods describing its characteristics. This simple syntax makes class definition straightforward. Inside the class, you define attributes, like characteristics, and methods, which are actions objects perform. Attributes store data specific to each object, like a car's color. Methods are functions within the class that operate on an object's data or perform tasks. For example, a dog class might have attributes like name and breed, and methods like bark. Each dog object has its unique name and breed, but all dogs share the ability to bark. This models real-world entities with distinct properties and shared functionalities. You'll often see self as the first parameter in class methods. This self refers to the instance of the object itself. When a method is called, Python automatically passes that object as the first argument, conventionally named self. It refers to its own data. It allows methods to access the object's attributes and other methods. If a dog object calls its bark method, self refers to that specific dog object, enabling access to its name attribute. This self-referencing mechanism is fundamental to object interaction. Now that we have our blueprint, let's create some actual houses, or in programming terms, objects. An object is a concrete, tangible entity built according to its class specifications. It's the actual working instance, occupying memory and ready to perform actions. An object is an instance of a class, a concrete realization of the blueprint. While the class defines the general structure, an object represents a specific instance, like Buddy, the golden retriever. Each object is unique, sharing the same fundamental design and capabilities. To create an object, you simply call the class name followed by parentheses, passing any necessary arguments. For our dog class, you might write my_dog equals dog. This instantiates a new dog object, assigning its name and breed. Each object created from the same class will have its own unique set of data, even though they share the same structure. For example, dog1 equals dog and dog2 equals dog are both dog objects, but hold different name and breed values. This distinct data makes each object unique. You can access an object's attributes using dot notation like my_dog.name. This allows you to retrieve or modify the specific data associated with that object. For instance, print would output Buddy. It's a straightforward way to interact with an object's properties. Similarly, you call an object's methods using dot notation followed by parentheses, such as my_dog.bark. When you execute my_dog.bark, the bark method is invoked for the my_dog object. This action would then produce woof, demonstrating how objects perform behaviors. Now, let's talk about constructors, specifically the __init___ method in Python. This special method sets up a new object immediately after creation. It's the first code that runs when an object is instantiated, ensuring it's in a valid and usable state. The __init___ method is a special method automatically called whenever a new object is created from a class. You don't explicitly call __init___. Python handles this behind the scenes. This automatic invocation ensures every new object is properly initialized. Its primary purpose is to initialize the object's attributes, setting its initial state. For example, when creating a dog object, __init___ would assign its name and breed attributes. This ensures the dog object has its fundamental characteristics defined upon creation. When you create a dog object, the __init___ method takes the name and breed you provide, assigning them to that specific dog instance. So, dog passes these values to __init___, setting self.name and self.breed. Without an __init___ method, your objects would start without initial characteristics, making them less useful. You would have to manually set each attribute after creation, which is error-prone. The __init___ method streamlines this process, ensuring essential attributes are configured correctly. You can also define default parameters in __init___, providing fallback values if arguments aren't explicitly given. For instance, a dog class might have a default breed of mixed. This flexibility makes your classes more robust, allowing for simpler object creation. Next, let's explore destructors, represented by the __del___ method. While constructors handle object creation, destructors finalize an object before it is removed from memory. They perform cleanup operations when an object is no longer needed. The __del__ method is called when an object is about to be destroyed or garbage collected. This typically happens when an object's reference count drops to 0. Python's garbage collector identifies it as eligible for removal. Its purpose is to perform any necessary cleanup, like closing file connections or releasing external resources. For example, if your object opened a file, __del__ could ensure it's properly closed. This prevents resource leaks and ensures no lingering open connections. However, it's crucial to remember that __del__ is not always reliably called in Python. The exact timing of garbage collection is not guaranteed, and __del__ might not execute immediately. This unreliability makes it unsuitable for critical resource management. Python's garbage collector handles memory management automatically, so __del__ is rarely needed for basic cleanup. Python efficiently reclaims memory from objects no longer referenced, without explicit destructor calls. This simplifies memory management for developers. For resource management, context managers using the with statement are generally preferred as they guarantee cleanup. The with statement ensures resources are properly acquired and released, even if errors occur. This deterministic approach makes context managers safer and more reliable. Using __del__ can also lead to unexpected issues, especially with circular references. If two objects refer to each other, their reference counts might never drop to 0, preventing __del__ from being called and potentially leading to memory leaks. This complexity is why __del__ is discouraged. In summary, classes are blueprints, defining structure and behavior. Objects are instances, concrete realizations with unique data. The __init___ method acts as a constructor, initializing objects upon creation. The __del__ method, a destructor, handles cleanup before an object is destroyed, though used sparingly. These roles are key to OOP. We've covered the foundational concepts of Python classes, objects, constructors, and destructors. You now understand how to define a class, create objects, initialize attributes using __init___, and the limited role of __del__. This knowledge forms the bedrock for building organized Python applications. The best way to solidify your understanding is to practice. Try creating your own classes and objects, experimenting with different attributes and methods. Think about real-world entities you could model. hands-on coding is invaluable. As you progress, explore more advanced OOP concepts like inheritance and polymorphism. Inheritance allows classes to inherit properties and behaviors from others, promoting code reuse. Polymorphism enables objects of different classes to be treated as a common type, leading to more flexible code. These concepts build upon today's foundation. Thank you for watching. We hope this guide has demystified Python's object-oriented features for you. Our aim was to provide a clear introduction to classes, objects, constructors, and destructors, making these powerful concepts accessible. This foundation will empower you to write structured and efficient Python code. If you found this video helpful, please like, comment, and subscribe for more programming tutorials. Your engagement helps us create more valuable content and reach a wider audience. Share your thoughts or questions in the comments below. Keep coding, keep learning, and unlock the incredible power of Python. The world of object-oriented programming is vast and rewarding, offering endless possibilities for innovative solutions. Embrace continuous learning, and you'll soon be building amazing things with Python and OOP. Happy coding!